harmonic conjugate of a real value function, right? Still on harmonic conjugate of a real value function. So we'll be using the other method, meaning that we want to see the possible method we can also use to solve a particular question. You know, what we did previously was that we made use of the partial derivatives, right? Yes. Using the Cauchy-Riemann equation, we integrated, then we also differentiated. But in this case, do we have another method that we can use? Yes, we have another method. This method is called the what? Milne Thomson method, right? This is very easy. This is one of the easiest methods compared to the first method, which was the partial derivatives. So this method, it is telling us that it helps us to find f of z directly. You know, for the previous one, what we did was that I want to know the analytic function, which is what? F of z. The first thing I'm going to do, find u function, meaning find the function of u, which is as a result of x and y. Find v, which is a function of x and y. Then once you've known these two functions, or once you found these two functions, then substitute into what? F of z. But in this case, you are going to get your f of z directly. You are going to what? Get your f of z directly. So for this particular method, you just need to know the steps. You just need to what? Know the steps, then follow the steps. We have about 5 steps. We have what? About five steps compared to, you will see the space I'm going to use now. Given a particular question, probably just something like this. It's not stressors at all. Alright, the first method is that, or the first step, your first step, giving u as a function of x and y, and v as a function of x and y. You know, this is what we'll be giving. Given this, meaning you have to find the imaginary function, right? Let's say you are given this function, this real value function, meaning you have to find what? The imaginary part, which is the conjugate. Let's say you are given this, meaning you have to find what? Real function. So this method, it works vice versa. It's either you'll be given this, then find the imaginary, or you should be given the imaginary part, then find the what? Real part. So meaning they are not saying step 1, given this function, express this function, or you say write this function as number 2. Given this function, write this function, okay? Given this function, obtain the partial derivatives, meaning the partial derivative of u with respect to x, the partial derivative of u with respect to y. For this particular function, find the partial derivative of v with respect to x, and the partial derivative of v with respect to what? Y. Number 3, write these partial derivatives as partial derivative of u with respect to x minus I, partial derivative of u with respect to y, and partial derivative of v with respect to x plus I, partial derivative of v with respect to y. Meaning that given a question, given this function, find the partial derivatives. That's your step 2. Step 3, compute this. We saying compute this. We are saying what you've differentiated, substitute it or express it as this, right? When given this function, you want to find the conjugate of this function, meaning v function. This is the step. Once you've solved this, then express your derivatives in terms of this. Similarly for this, let's say you are given this function and you want to find this, which is the conjugate. Once you've differentiated this, express this as this, right? This is step 3. Step 4, let f of z is equals to partial derivative of u with respect to x minus I, partial derivative of u with respect to y, or partial derivative of u or partial derivative of v with respect to x plus I, partial derivative of v with respect to y. Number 5, substitute x equals to z and y is equals to 0. Number 6, integrate f of z. F of z. I said using Milne Thomson method. Milne Thomson method. We have about 6 steps. The first step is what? Given this function, differentiate your function, right? Compute this. Let f of z equals to 3. Meaning what you've computed, write it as what? F of z. Anywhere you see x, substitute it as what? Z. Anywhere you see y, substitute it as what? 0. Then lastly, integrate f of z. Your result becomes the analytic function. Can you see what I said? This method, it helps you to find f of z directly. Up to step 6, integrate f of z. Meaning that your result, which should be the function, meaning your function, which should be the result of this integration, is the analytic function you are asked to find. Now, let's use we'll take 2 examples. We'll be taking 2 examples for this particular method. Though we are still using the previous example, right? We are still using the previous example just to see what we are saying. Now, take down example 1. Example 1. This example says that given that u is equals to x squared minus y squared. This step, what you just need to do, just follow the steps. This is number 1, this is number 2, number 3, number 4, number 5, number 6. No stress. I'm just following what I have on the board. Now, given this function, question says that find the harmonic conjugate of this function, right? By harmonic conjugate, we are saying that find the corresponding function of v that will satisfy the Cauchy-Riemann's equation for the analytic function, right? That will satisfy what? The Cauchy-Riemann's equation for the analytic function. Given this real value function, what's your first step? Check if it is an harmonic function. Check if it is what? An harmonic function. You know, this was the previous example. This was the example we did previously. So we want to see how we can use this method to solve it. So we said, number 1, given this question, check if this function is an harmonic function. By harmonic function, we are saying that the Laplace 2-dimensional equation must be met, right? So we are saying by Laplace 2-dimensional equation, meaning that this is your Laplace equation, is equals to what? Alright, it must be equals to what? 0. Now let's solve this. Du over dx. What is your du over dx? 2x. Then the square u over dx square becomes what? That's equals to what? That's equals to 2. Similarly, the partial derivative of u with respect to y. What do we have? Negative 2y. Therefore, the second derivative, what do you have? We have minus 2. Now substitute, meaning I'm having 2 plus all into bracket negative 2 is equals to what? 0. So I'm getting 0. It means this given function is what? Is an harmonic function. Because it is an harmonic function, it means that the harmonic conjugate exists. The harmonic conjugate exists. Now let's implement these steps. Step 1, let's do this together, please. Step 1, given this function, in this case, this is the function given. Step 2, find the derivatives. So we found the derivatives already. Step 3, what is step 3? Compute this, right? So let's compute this. It means that I'm substituting values. So I'm having, following step 3, it becomes what? Identify your partial du dx and partial du dy. What do you have?
2x.
You are saying 2x minus I multiplying what? Minus 2y. So it implies 2x plus I 2y, right?
Yeah.
This is step 3. Step 4 says what? Let f of z. So you are saying f of z is equals to 2x plus j2y. Right? 2 is common, right?
Yeah.
So let's say f of z 2y into bracket s plus jy. Alright, now from here we said substitute x equals to z and y equals to 0. So I'm having 2y into bracket z plus I multiplying 0. Therefore, f of z is equals to what? 2z. You should give me 0. Alright, the last step is what? Integrate f of z. Now let's integrate f of z. Integrating f of z, it implies that integral of 2z, which is equals to what? Z squared plus c. Where z is equals to what? X plus I y. Meaning f of z that we've gotten as z squared plus c, I can substitute this z. So I have what? X plus iy squared plus c. Now let's solve this. What do I have?
X squared. Okay, sharp.
Right? This multiplied by this.
It's not long before that.
This multiplied by this. This multiplied by this.
Minus x and then yes, minus y squared. X squared plus 2xy minus y squared.
Right? So from here, what do I have? X squared minus y squared plus I 2xy. This is equals to what? F of z. Can you see that? Can you see that? Any question? Meaning that, given this question, what's the harmonic conjugate? 2xy. Instead of finding the harmonic conjugate, then substitute into the analytic function. We said this particular method helps us to find what? F of z directly. It helps us to what? Find f of z directly. And we've seen that. We've seen that. My plus c, okay? I have plus c. I have plus c. Yeah, from complex number. I squared is equals to -1. This multiplied by this, you have this. This multiplied by this, ixy. This multiplied by this, I square, y square, right? S square plus I2xy. Then anywhere you see I square, substitute -1 from complex number. So you have -1 multiplying y square. By the time you solve this, you are saying S square minus y square plus I2xy plus c. So this is f of z. Meaning this is the harmonic conjugate. Given this function, your harmonic conjugate, which is a function of x and y, is equals to 2xy. So instead of using the partial derivative method, you can use what? The Milne Thomson method. I know you like this method. Where z? Yeah, okay, this is where the confusion is coming from. From complex number now. The cartesian form of complex number. This is my answer. This is what I got. Z squared plus c. Then I recall that z is equals to s plus I y. Where am I getting the idea from? From complex number. Generally, given a function z, what's the complex representation? X plus what? S plus iy, or you say s plus jy. So that's what I did here. Or you can use your usual representation of complex number in Cauchy-Riemann's equation, which is what? U plus jv. You can use u plus jv, a plus jb, you still get the same thing. But I'm using what? Do you even know why I'm taking x plus jy and not u plus jv or a plus jb? Do you know why? I'm using it because my analytic function is emphasis must be a function of x and y. Must be a what? Function of x and y. So that's it. So I'm taking this out of all the whole Cartesian form of complex number. So this is another method to go about this.